All right, so since several people asked on me doing a test 2 review, I thought that since we did a actual review in class with examples, I would just run through kind of a concept list to let you know what to look out for. That's going to be on there, and that way you can kind of find your own examples from things that we've done in class, as opposed to making this just a whole step through type review video. So the first thing that we're going to talk about on the test will be derivatives. Okay. And the basic derivative rules that we learned were the power rule. So that is something like if we have a function of, say, 3x squared, then the derivative of that, we bring the power down, multiply it by whatever's out front. So I have 2 times 3 is 6. And then I subtract 1 from the power to make my new power. So I would have 6x. All right. And then we had the product rule. The product rule is when we have two things being multiplied together. Two maybe separate functions, you could say, like x plus 2 and 2x plus 4. Yeah. And the product rule tells us that we do the derivative of the first. So the derivative of x plus 2 is 1 times the second plus the derivative of the second times the first. So we have the derivative of 2x is 2 times x plus 2. And for this test, I'm not going to ask you to simplify anything. So don't worry about the simplification part. Then we had the quotient rule. And remember, if the quotient rule, we had some kind of function that was a rational expression. So we had some kind of high function and low function. And we said that the quotient rule was low times the derivative of high minus high times the derivative of the low all over the bottom squared. Okay. As long as you can do that part, that's fine with me. Again, no simplifying. I'm not going to ask you to simplify anything to do any kind of heavy algebra. I just want to see that you know the calculus rules. And then the last rule we had was the chain rule. And the chain rule is when we have some kind of function inside of a function. So say like x plus 2 to the second power, right? We can do the chain rule to this to define the derivative, and we do that by bringing the power down, just like with our power rule, multiply it by whatever's out front. So I have 2 times 1 is 2. I copy my inside function, and then I subtract 1 from the power to make my new power, which this would be 2 minus 1 is 1. But then with the chain rule, I have to chain on the derivative of the inside function at the end. The derivative of x plus 2 is 1. Okay, and again, don't do any algebra simplification. That's a fine enough answer for me. All right, so those are the 4 basic derivative rules that will be on there. All right, the next thing we're going to talk about is critical values. And I want to give you the process of solving for the critical values. So if we have a function, f of x, all right, to find the critical values, first we take the derivative. So we have f prime of x, all right. Then we set equal to 0. So we are going to solve the function of x is equal to 0. We have 2 basic options that we could come up with here. One being a quadratic. So if f prime of x is a quadratic, so you have like ax squared plus bx plus c, then you need to use the quadratic formula, which is that the negative of b plus or minus the square root of b squared minus 4ac all over 2a. Okay. If it is linear, so it looks something like this, like 2x plus 5 or something, right? Then what you'll do is you'll have 0 is equal to mx plus 5, or mx plus b. You'll subtract the y-intercept over, all right? And then you'll have to divide by whatever accompanies the x. And so you get left with the y-intercept divided by the slope and the negative of it, all right? And whatever values you get out are your critical values, okay? So these x values are your critical values, okay? Then we need to talk about increasing and decreasing, all right? So find critical values would be step 1, again, by whatever means. So follow the same method that we just used with question 2, find the critical values. But then what you're going to do is set up your table with your critical values. Say our critical values are, let's go with -2 and 0. Okay, so if we have a quadratic and we get 2 critical values, then I would set up my table and I would look from -infinity up to -2. Then I would look from -2 to 0, and then I would look from 0 to infinity. Okay, and what I'm looking at is my derivative. So my f prime of x. So when I find my derivative, I'm going to plug these numbers back in. I pick out a huge number between -infinity and -2, like -100. Plug it into my derivative. And let's say I get a negative out. Okay. Then I'm going to plug in something between -2 and 0 into my derivative. So maybe like -1. I plug it in, maybe I get a positive. And then I'm plugging something between 0 and infinity, maybe 100. Plug it into the derivative and I get another negative. So then this thing is increasing from -2 to 0, but it is decreasing from -infinity up to -2 and 0 to infinity. Okay, so that is how you check to see if this thing is increasing or decreasing. All right. So then the next thing I want to talk about is with absolute extrema. Absolute extrema happens on an interval. So like on the interval we used in the test review was 0 to 4. Okay. So I'm going to find my critical value. So using the same process as we used in question 2 here, or example 2, find the critical values. I want to check the endpoints and the critical value on the interval. Okay, so let me show you what I mean by that. Let's say that we take a derivative, we set it equal to 0, we find our critical value, and say we get like -1 and 3. The only value that's my critical value that is on the interval from 0 to 4 is 3. So I only have to worry about 3. I can ignore -1. Okay. Then I'm going to go back and in my original function, okay, my OG function, so to speak. That was a horrible dad moment there. All right, so I'm going to plug in 0. I'm going to check 3. And I'm going to check my endpoint 4. because my critical value 3 is on the interval, so I'm checking in the original function. The highest value, the highest output, is the absolute max. The highest or the lowest output, so the output being the number that we get out by plugging it into the function. So the lowest output is the absolute minimum. Okay. So the absolute min takes care of the lowest value. And it happens, like we would say absolute max at x equals, say 3. And then absolute min at x equals 0, for example. Okay. So that concludes all of the calculus part. As you notice, 2 through 4 uses the same concepts. Take a derivative, find the critical values. Okay, so make sure that you know how to find critical points. That's the big thing, is being able to find those x values when you set the derivative equal to 0. And our two methods for doing that, if we have a quadratic, we go use the quadratic formula. If we have linear, then we kind of follow this process and just solve for x with the two-step equation. All right. And so now let's talk about exponentials. So with our exponentials, we have, if we have something in the form of y equals ca to the x, our conditions were that if a is greater than 1, we have growth. And if a is between 0 and 1, we have decay, right? Then c is our initial value. And the only thing that we're going to use with exponentials on the test is being able to identify growth and decay. And so something to make a note of is that the initial value c has no bearing on if we have growth or decay. The only thing that we have to look at is this a value. All right? And then our other form was with continuous growth and decay, was when we had something like ce to the kt. If k is positive, we have growth. If k is negative, we have decay. So using those, you can know just by looking at it if it is growth or decay. All right. So that's what you'll be tasked with. And then for the last question, you'll just fill in a table. So make sure you're comfortable with plugging exponentials in the calculator. Okay. Because all you're going to do is fill in a table. And then you'll estimate solutions. So I'll ask you something like, when is this function equal to 6? And you will have to be able to tell me what input value, so whether it be x, t, whatever, what value of that makes that approximately 6. Okay, you won't have to solve using logarithms. You can if you want to, but you do not have to. Okay, so this, you can just use the calculator to estimate just by plugging in values. All right. So this kind of concludes our test review. Again, in class, we did more problem-oriented test review. So for this video, I just wanted to maybe do concept review, give you some thought processes on how to step through these problems. All right. If you have any questions, please feel free to email me. And as always, have a great rest of your day.